Our company has 3 Jess machines now, so we've been sort of expanding up as the sort of demand has come in. So yeah, that's the main platform we've got at the moment. Been using it quite heavily over the last few months, looking at sort of biomarkers, sort of characterizing expression in different cell lines, and we've also been using it as a compound screening assay, looking at changes in phosphorylation of a protein across like a dose response curve. So something you wouldn't have thought to do with a traditional Western, but it's possible with a Jess to sort of see that level of quantitative detail.
I actually find Jess really, really easy to learn because we were lucky to have a demo before, an on-site demo with some of the application specialists, and there one could already see, okay, how does it work, what's the different steps and so on. And then of course we had the in-depth training again, which was really helpful to again remember what has to be done. But then afterwards it's just easy, and the most time-consuming thing or most challenging thing left is actually to think about how you run your experiment.
So I started using the WES, which is actually the first instrument that I came across. I thought it was quite nice, and we did mostly looking at protein expression in cell lysates. And now at Charles River we have a Jess, and I think it's really nice because we can also detect in the fluorescence channel, and then we can multiplex more species. And this we all use for different applications, such as protein expression, protein stability, also protein degradation assays we do a lot. We also look at knockdown or knockout samples and validate whether it worked or not. And also for our screens we use it as a validation technique. And then we look more closely at the targets.
With the envy of the entire university basically, because people are always like, oh, you're the one with the fancy WES machine. With our studies, we mainly work in brains, so with that we only get a small sample size because we're only looking at a very specific region within the brain. So in that way, with the WES, we're able to measure multiple different targets in these small samples, and we know that when we're doing it with a high reproducibility because we're getting the same results across different studies.